Welcome back, students. This is the Q&A session 13 from the playlist of alternating current. The topic is the resonance in LCR circuit, and this session is in a continuation of the session number 12, in which we have studied about the condition of resonance in the LCR circuit, and we have learned that an LCR circuit is in resonance when the current in the circuit is maximum and the impedance is minimum, and impedance is minimum when XL is equal to XC, or omega L is equal to 1 upon C omega, because this inductive reactance is equal to omega L, and this capacitive reactance is equal to 1 upon C omega. So from this relation we get omega is equal to 1 upon under root LC. So when the LCR circuit is in a state of resonance, then omega is equal to 1 upon under root LC. So in this question, there is a series resonant LCR circuit. The voltage across the resistor is 100 volts. The value of the resistance is 1 kilo ohm, and the value of the capacitance is equal to 2 microfarad. The resonant frequency is equal to 200 radians per second, and so we have to find the voltage across the inductor. So we have been given here 4 options, and we have to find the correct one. Now the voltage across the inductor, that is VL, is equal to I XL. So this can be further written as I into, now XL is equal to omega into L, where L is the inductance of the inductor, omega is the resonant frequency, and this I is the current which is flowing in the circuit. Now we first of all try to find the value of I. Now here the voltage across the resistor is 100 volts, and the value of the resistance is 1 kilo ohm. So the current which is passing through the resistor will be equal to V upon R. Now here it is 1 kilo ohm, so this in ohms it will be equal to 1000 ohms. So this is equal to 0.1 ampere. Now this is a series LCR circuit. So the current which is flowing through the capacitor and the inductor will also be the same. So the value of the current which is passing through the inductor will also be equal to 0.1 ampere. Now omega is known to us. Now we have to simply find the value of L. So for finding the value of L, I will be using this formula, that is omega is equal to 1 upon under root LC. So if I square this equation on both sides, so I will be getting omega square is equal to 1 upon LC, or L will be equal to 1 upon omega square into C. Now omega is equal to 200, so 200 whole square multiplied by the capacitance of the capacitor, which is equal to 2 microfarad in this question. So I will be converting it into farad, so this will be equal to 2 into 10 to the power minus 6. So from here, the value of this inductance will be equal to L will be equal to 10 to the power 6. This is 10 to the power minus 6. So when it is coming into the numerator, it will be equal to 10 to the power 6, and this will be equal to 2 into 4 into 2, 8. 8 into 10 to the power 4. So this is equal to 100 divided by 8, or this is equal to 12.5 Henry. So the inductance of the inductor is equal to 12.5 Henry. The value of the current which is flowing in this LCR circuit is equal to 0.1 ampere, or we can say the value of the current which is flowing through the inductor is also equal to 0.1 ampere, and omega is already given to us. So the voltage across the inductor, that is VL, will be equal to I is equal to 0.1 into XL. XL is equal to omega L. Omega is equal to 200 into L. L is equal to 12.5. So this will be equal to 1 by 10 into 200 into 125 by 10. So this is equal to 250 volts. So the voltage across the inductor is equal to 250 volts, and the correct option is B, that is 250 volts. So thank you very much for joining this session. In the next session, I will be again coming up with a different type of a question from the same topic, that is resonance in the LCR circuit. So till then, have a nice day. Bye.